Thanks so much for joining us, guys. We have a really awesome presentation ready for you all. We have Lindsay Love here. I'm going to introduce her in a second, but I had to just mention that I'm kind of a fangirl over here. I'm really excited for today's presentation. Wish Jose could join us, but he'll catch us all next time too. All righty. So Lindsay Love became an architect because of her passion for building with natural materials, which is really inspiring. In addition to being a licensed architect, she's also a certified passive house tradesperson and a Living Future accredited professional. Lindsay serves as the current president of AIA Idaho and is the national AIA 2030 working group. She's on that group as well. Building in the field with both natural and conventional materials has greatly informed her practice and expertise, which is really rad. And having practiced in the industry for over 20 years, she now primarily consults for other architects and owners and builders who are seeking to implement natural materials into their high performance projects. Lindsay enjoys working in the field and providing design, detailing, energy modeling, carbon accounting, estimation, sourcing, installation, repairs, educational services. Honestly, Lindsay can do it all. So I am excited to hear her presentation today. With that, I will let her take it away.
I just want to acknowledge that this is really, it's Passive House or Insulating with Natural Materials 101, but it's really a 101 course for people who are Passive House informed. Um, so if we need to dive into some of the topics a little bit more at the end, we certainly can. Um, as Sarah said, I went into architecture because I wanted to design and build with natural materials, and that passion has just been reinforced over the time of my career. And I've really realized that I think as humans, we have an innate desire to be surrounded by materials our ancestors were surrounded by. So this passion, this connection to nature really drives me in the work that I do. But from a practical perspective, as passive house practitioners, you're all very practical, right? Um, let's talk about some of the fundamentals and the boxes that these materials check. They're not always easier to install, but some of them can be than some conventional materials. We already know about the carbon storage potential, or at least a lot of reduced embodied carbon. Sometimes they can be more locally available. They are almost always non-toxic. They can be multifunctional and like stacking functions, which can be a cost-effective approach. They're just naturally more fire resistant generally, and we don't have to add a bunch of chemicals, which are often forever chemicals, PFAs, are what are in a lot of insulations that have fire retardants in them. They are much more repairable. They can be part of a socially just economy, biodegradable, hygroscopic, which means that they are more durable over time and mold resistant. And I think the highlight for me is that they can lead to really creating elegant assemblies. And Joe Steebrook, I don't know how to pronounce his last name, he summed it up when he said, highly insulated wall assemblies have much lower drying potentials, i.e. more risk, than poorly insulated wall assemblies. And it gets worse. Newer materials don't handle the water as well as older materials. It's just because older materials happen to be natural, we didn't have the industrial processes that we have today. So talking about natural insulations, I want to just look at a handful of the plants that are sources of the materials that we are going to be looking at. I'm super curious if anyone here has ever seen a product made with just natural fluffy cotton insulation. I have not, but I kind of bet someone's done it. We mostly know cotton insulation in the form of denim, which is a byproduct of the fabric industry. And then you can kind of compare hemp, reeds, and straw all together. You can see their plant bodies are quite similar. Hemp, of course, is much bigger. Reeds and straw are smaller. Reeds are even a little bigger than straw. And there are a lot of different kinds of reeds and straw. I'm not going to take a deep dive into reeds. We don't use it in North America, at least not in at any scale that I'm familiar with. We do use straw, and there are lots of different kinds. Primarily, we're using rice, wheat, and barley. Um, and then the slide on the left, I think, is really important because it highlights and speaks to the embodied carbon factor. All plants store carbon in the soil and in their bodies. Some are more effective at it, and as we can see with wood, some require a lot more emissions to harvest and process. But one of the interesting things to note about almost all of the insulations I'm going to be talking about today, they're pretty much all byproducts of some industry. Um, Hemp is the only one, at least in the US, that has to be grown as a virgin crop for building because of the processing equipment we have here. And I know there's a lot of hemp folks on this call, so if I am incorrect about that, please correct me. On the reverse side of that, though, hemp is fantastic for soil regeneration. We're going to be talking about a couple of different categories. In high performance walls, we often use both in-cavity and exterior insulation. And some basic principles apply to like this hybrid strategy of in-cavity plus exterior. So we're going to be talking about moisture management rules of thumb, some common air sealing options, and the pros and cons of those. And then we'll dive into some of the product options and look at like sourcing and cost, ease of install, and where you can find stacked functions. This slide is a little overwhelming. There's a lot of options out there that are all natural. Well, they're not 100% natural necessarily in every case, but they are primarily natural materials. So on the left, we've got some panelized and bundled options that are taking raw fibers and just like packaging and bundling. Then we've got fluffy stuff that has a little more processing involved and is more often a byproduct. We've got bats that's still often a byproduct, and everyone's familiar with bats, right? You just fit them in the wall or the roof or the floor, whatever it is. And then the ones on the right, packed with binder, I'm not really gonna go into those at all today, just because those are the more like kind of radical options that honestly they're more traditionally used. They're more common traditionally and historically, but uh, it would require a lot of special expertise nowadays to use them. I just want to highlight though that there are products available that use hemp lime and or straw clay that you can find. And I bet some folks on the call could highlight some hemp ones, and I could identify a straw clay one if we want to in the end. On the exterior side of things, we've got a couple of options bundled. We don't really use reeds, again, like I said, in the US, but I wanted to give a shout out to thatch because it is making a big comeback in Europe and it's such a beautiful, rich material. And then on the rigid insulation side of things, we've got a lot of options here. We can get cork in the US. There is a new Hempitecture plant panel rigid hemp fiberboard insulation. And then we've got quite a few options of wood fiberboard. Only one is made in the US, but there are Canadian options, and then we can get European products as well. All right, so moisture management rules of thumb. They do vary by climate. I'm kind of going to approach this from a cold climate perspective. If you're in a warmer climate, you definitely need to refer to your code, potentially work with a consultant, run woofies. Be careful. So protection from exterior water is kind of the first rule of thumb to consider. I'm showing two examples with roof overhangs here. You don't have to have a roof overhang. If you don't, though, do you have a good rain screen detail? And then what is your exterior finish? And I like to think of exterior finishes as kind of a sacrificial layer. they're doing the protecting of all of the structural and insulation components of the wall. They are the thing that is going to need some maintenance at some point in time. And most of our clients are often seeking, like, I want a zero maintenance situation. I don't want to have to mess with it. But the reality is, I learned long ago, anything that is zero maintenance by default is going straight to the landfill at the end of its life. So if we can find ways to convince our clients that a little bit of maintenance is like really okay, um, we're doing better by the planet and each other. And I just want to highlight too that I'm super fortunate to live in a small hybrid house of, like, I've got a cellulose wall with wood cladding on the outside that's stained, and I've got a straw bale wall with lime plaster on the right of me. And I've had to do far more maintenance on the wood cladding. It's been over 10 years and I haven't had to touch the lime plaster. I think this year I might have like a couple of little repairs that are like this big to do. Um, and it's super easy to do. Just want to mention, like, your drainage and flashing. Those things are important, detailing around windows and doors. Do you need a weather resistive barrier? It depends on the layers of your system. There are some insulations that take the place of that, or they don't take the place, they act as that. And then your sheathing. Do you need sheathing, and where is it going to be located? All right, protection from water on the interior. In straw bale construction, they've developed a best practice of always including what we call a toe up, which is kind of a funny name. It's two sill plates. We use it in same thing in a double stud wall, but we fill that cavity between with something insulative, and we're kind of protecting the wall from, like, not protecting it from a catastrophic water damage event, but creating a place for the water to go in that event. So we use a material that is insulating, kind of like something that we would use below grade, that's hygroscopic, but not biodegradable. So in this case, you're looking at pumice in the toe up. It's got to be something that is not moisture vulnerable, that it won't rot and create more of a problem. And then the other factor on the interior side of things is, are your layers vapor open for drying? These are really best practices for any wall system, regardless of the insulation material. It's just, we want to be a little more careful with natural things, I suppose. All right. The big one to think about in any wall, regardless of whether you're using foam or something that is vapor open or natural, is condensation on your sheathing. Because the sheathing has a structural job to do, it's very important to keep it from rotting. So there's three methods that I like to practice in determining where the sheathing is going to go, and how much, like, outsolation am I using compared to interior insulation. The R value rule of thumb, running a woofy model, and or using vapor permeable insulation. Many of you might be familiar with Martin Holliday's information, and it's both available on Green Building Advisor, through Fine Home Building, and through Building Science Corporation. But they've developed this rule of thumb that is, the amount of exterior insulation is really driven by the R value of the interior insulation in order to keep that sheathing warm. So you can see in this chart that as your R value on the interior goes up, the R value on the exterior also goes up. And so at some point in time, like, this strategy maybe isn't productive or effective anymore in a super high performance, say, R30 to 50 wall. But I want to point out that this is developed specifically for foam sheathing. In all of the articles about this I have read, it's always referencing foam, because that's what the testing has been done with. Um, it's much harder to find testing of natural insulation materials because they're newer. But what happens when this R value increases? Your complexity increases, the cost increases, and if we're looking at embodied carbon, the embodied carbon just goes up and up. Unless, I guess, if you're using a natural insulation, I guess there's a world in which you could say, oh, it's carbon storing, let's just use a ton of it. But it does increase cost and complexity. So again, it becomes unproductive at some point. Um, I want to acknowledge that there are low or zero D GWP foams out there, which is great. And I still choose to avoid them. If you're a person or you have a project where you just cannot avoid it, then please by all means specify these low or zero GWP ones. But foams are still a plastic product. They are not biodegradable. They are still flammable. They are still full of chemicals. And they are still not, they don't let moisture move, and therefore they are potentially more detrimental to the durability of the building. So we want to remember that the main point here is we need to ensure that that sheathing can more than stay warm, we need to ensure that the drying capacity exceeds the wetting potential. And then what happens if we use vapor open insulation? So this is a study that was done in like 2011 by Building Science Corp. And it's not a natural material. Rock wool is natural technically, but is highly, highly processed with a lot of heat and energy involved. Um, uh, they compared the drying potential of the two different insulations in a hybrid wall system with sheathing in the middle. And you can just see the dramatic difference between the XPS and the rock wool, that the rock wool was significantly safer than the XPS. And throughout my presentation, I've sprinkled in these links that are, I think, being posted in the chat so that you can reference them in the future. All right, some air sealing options. These are pretty common things that you are most likely familiar with. Flash and bat, tapes and membranes, tapes, similar kinds of tapes in combination with sheathing, and then plaster and tapes is one that most people probably aren't familiar with. Flash and bat. I typically kind of ignore this one, but I want to acknowledge it because a lot of people do see it as like the best of both worlds. And in certain situations, it might be the best you can do. It offers a reduction, you know, if your other option is just all spray foam, it offers a reduction in spray foam. It does get you some air sealing, and it's a quick and easy air sealing, but is it durable? Foam, as you can see in this image in the middle, it has potential to crack because it becomes a rigid thing, but wooden buildings are not as rigid as we think they are. They definitely shift and move over time with moisture and the ground shifting for lots of reasons. Also, it's just not often installed well, and it can fail for other reasons. It can shrink. Um, and then I also just think of like any any spray foam that you're introducing into the building, unless the building is really completely safely treated like a hazmat situation and it is clear of people until it cures fully, you are introducing all of those people and their families to that material and to those chemicals. So I like to avoid it, even if there are zero GWP options. Um, Tapes and membranes. These are a pretty standard go-to nowadays, and I'm really grateful that we have these like smart membranes that exist that are so cost effective and functional, and there's so many different options for them. I think they have kind of changed the industry over the past 20, 15 years. We're still using a little bit of petro products, but a lot less. I can give a super quick overview of what they do. I imagine folks here are familiar with them, but instead of just being like a sheet of plastic on the wall on the interior or the exterior, depending on your climate, they actually respond to the climate and open up the pores in order to let moisture out that may get in. Vapor, that is. Um, they are used in combination with these super high performance tapes that are really cool and kind of take your skin off if you're not careful. Um, but they're, even though we're using some plastic, it is reusable. You could somewhat reuse it in another building in the future. They do require a little bit of a learning curve for install, um, and they definitely require coordination of the framing sequence. Um, and they require a little bit more labor than spray foam, but once your crew is trained, it's really not, it's just, it's a new thing. It's not more. Tapes in conjunction with sheathing is an option that I like a lot. I think it's a very smart option. They don't all work as well as others, but when we're using natural insulations in high performance walls, high R value walls, we're probably looking at using plywood instead of OSB to begin with for various reasons, to eliminate the amount of glue and chemicals, as well as to create a more vapor open assembly. So plywood works a lot better than OSB as an air barrier. And then there are various tapes, and there's this great article that you could refer to if you wanted to dive into that to learn exactly which materials you wanted to specify. Um, there are, I think that this can be part of a really elegant assembly because you can skip adding an additional layer. Um, Again, it's reusable, and we've reduced a lot of flammables and embodied carbon. Tapes and plaster, or I should say maybe plaster and tapes. Plaster, like a thick earthen clay or lime plaster, or cement plaster if you're in the cement realm. Although cement doesn't work well with natural insulations very well, it is a very effective air barrier. The part that it's vulnerable at is at the junctions with adjacent materials and if you have any penetrations. So there are these tapes that are developed from the same companies that have developed the membranes. These tapes work very well and they just can get embedded into your plaster. All right, now we are diving into some of the products, which is the fun part. And I'm not going to talk about every single product that I showed on that first slide. There's too many of them. But I do want to talk about some of the ones that are more commonly used, or they're kind of gaining a following in the US, becoming more usable and more conventional. They're more seen as conventional. Structural insulated straw panels. And there's two different types of them in the US. We've got these ones with very long straws, and then we've got some that are with chopped straw, which I've included in the fluffy category. So we'll look at those later. They are really cost comparable to high performance options. I've done a lot of evaluating of the different systems and have even been working on developing this tool that someone could input their project criteria and client requirements that would help you determine which panel system is right for you. They're very easy to install, just as easy as any other kind of pre-manufactured panel. The R values of the walls are typically 30 plus, but they do have, there are options that are less, like in the code minimum realm. They offer, some of them offer really flexible finish options. Like you can apply plaster directly to some of them, or maybe one side of them, but not necessarily the other side. And then otherwise, there's enough framing in the panels that you can attach any kind of cladding in any situation. It is best to use these with a vapor open exterior insulation or a rain screen or combo. And the new frameworks, rare forms, and building integrity panels all do have structural sheathing on the exterior plywood. You can get to a 2-hour rated wall. Some are PH certified, Ikugakon, coming from Europe. And the costs of them do vary quite a bit. If I'm helping someone evaluate the cost of their assembly with these alternative less conventional materials, we have to get to where we're actually comparing apples to apples, because it's really easy for a contractor to say, oh, the straw bale and plaster wall is like so much more expensive than a double stud wall with all the other things. But the fact is they're just not thinking in terms of the stacked functions that this more simple assembly provides. So they're leaving things out. All right, I gotta kind of speed through this a little bit. I wanted to share just like these are some large scale projects that have been completed with these types of panels in the US. The one on the bottom is in Europe. I wish I had time just to share the amazing scale of projects that are being completed in Europe. We are so far behind in the US. All right. Compressed and wrapped panels. These ones are, I'm not going to spend a ton of time on these. They're really not common, at least in my cold climate or my market. I do think they have potential to potentially sometimes replace drywall. They can add some sheathing support, and they're not plasterable, but you can paint directly onto them. So there, I think, is a world in which they can be relevant in the US. They're just not as widely used as some other things. Here are a couple of very different scales of projects like those, or with those materials. All right, and fluffy. And I know that Edie Dillman was on here. I am apologetic because I didn't include Be Public or Collective Carpentry. My brain was just sort of straw focused, but like Be Public and Collective Carpentry are fantastic structural insulated panel options for fluffy types of insulation. And I believe they use just the cellulose, the newspaper kind. I'll go into the products in the next slide, but these are all super cost effective. The wood is a little bit more expensive. The install is something that some contractors may grumble about a little bit. I think contractors might like the wet installation better. Cellulose can be known to be messy. And that is why I chose to highlight the cardboard cellulose company, because it is a cleaner install than the newspaper if you're site installing it. If you're installing in a panel, it's a non-issue. Let's see, they all are going to require sheathing anywhere where sheathing would be required. They're all very fire resistant and fairly available. Chop straw you can get pretty much anywhere. It's used as animal bedding. The cardboard cellulose there's only one company that I know of, but regular cellulose, the newspaper kind, you can currently buy it at any big box store. The cardboard one is interesting because newspaper is becoming less available and cardboard is becoming more available. And then wood is a little, you can't buy it at Home Depot yet, but you can buy it from regional distributors throughout the US. Products in cavities. This is where I was going to mention Be Public and Collective Carpentry. Savic is a great panel company, structural insulated straw panels in Canada. Strategy is kind of a one-off small scale project in Utah that is looking to grow. Craft House is based in Maine. They're also wonderful. Clean Fiber is the cardboard option, and then Timber HP is the product we can get in the US. And these images just show the actual install process in case that seems mysterious to anyone. The one on the right is a wet install. The one on the left is like a dense pack install dry with a membrane. Yeah. Membrane holds it in place. All right, we're getting close to the end. Exterior options. I really love wood fiber board insulation. I think it has a lot of potential to make big impact in the market. It is available worldwide. In the US, it's mostly available, I think, through specialty suppliers. Um, Global Wholesale is one of them. 475 is another one, and a potentially Small Planet Supply. If other people know other suppliers, please put them in the chat if you'd like to. They are more expensive than XPS, and that cost variable does vary depending on the one. But if you are comparing the stacked functions of, like, some of them provide shear support, this MSL product can potentially replace your sheathing. And then I believe both Timber and Timber HP, Gutex, and Styco, I believe they can all be plastered directly too and can serve as a WRB. And then the last one is cork and hemp fiber. Cork is just so cool, and it's available through a company in Texas throughout the US. Mood Tower Austin is the Amarim cork solution supplier. Maybe there might be others that I'm unaware of. It is the more expensive one, but it can serve as the cladding, which is great. The plant panel by Hempatecture is kind of the newest one on the market. And I did have the opportunity to participate in the testing of lime plaster adhered directly to both plant panel and the wood fiberboard insulation. The strength of the bond has been tested and the durability. So we're trying to catch up on solutions in the US that are fairly widely used in Europe. And I believe, yeah, that is the end. So I'd love to offer the rest of the time for questions and conversation.
Awesome, Lindsay. That was so cool. I don't know why I'm like partial to cork. We have some really cool cork exterior insulation at Small Planet called Thermocork that's really pretty. I just like how dark it is. Anyway, that was awesome. There's so many cool materials out there. I feel like this is a topic that people are kind of getting more and more excited about just because it's like, oh my gosh, cool, we can use this. And it's like, yeah, you totally can. And you can like treat this and that with other things, especially other like low VOC kind of materials and whatnot. Anyway, we do have some questions. Before we get into that, though, I'm going to throw it over to Zach to give a quick thank you to our sponsors who are awesome with us today.
Great. Thank you, Sarah. I appreciate that. Yeah, so I just want to take a moment to thank the fine organizations that make our work possible here at Passive House Accelerator. So first, a thank you to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority. Thank you, too, to our founding sponsors, 475 High Performance Building Supply, Ingui Architecture, Partel, Rockwool North America, and Zola Windows. And thanks to our champion sponsors, Bewizo, Cascadia Windows and Doors, European Architectural Supply, Facro, Icon Windows and Doors, Intelligent Membranes, LG Air Conditioning Technologies, and Source 2050. And thank you to our patron sponsors, Brennan, Holstrom System, Inotech Windows and Doors, Lamelux, RDH Building Science, and Sanderson Sustainable Design. Thank you, sponsors.
Awesome. Thank you, sponsors. We couldn't do it without you. So we have Q&A going up right now. If y'all have been here with us before, then you kind of know the drill. But if you haven't, Kim is going to post kind of a queue essentially, and I am going to invite you to hop off of mute and to ask your question if you are on the call and if you're comfortable with that. If not, I'll totally read off your question for you. And it looks like we have up first Nordby, if the G and the N are to be said that way. Otherwise, G Nordby. It looks like you had a question. If you're still on the call, and it looks like this first one was kind of about fertilizers and whatnot, annuals and perennials. If you're still on, I'd love you to hop on and ask that. Always going to give someone a second to find the mute button. You know, if you're like me, you're slamming it and it still doesn't unmute for you. I'm going to give you a quick second and then I'm going to go ahead and read your question/comment. Okay, your time is up. Alrighty. This is kind of a comment maybe for you, Lindsay, but if you can touch on it, totally. If you can't, that's totally fine too. But looks like this one was hoping we can get into fertilizer needs and annuals versus perennials, and whether roots are going to rot and release carbon as a result of harvesting. So if you're kind of have some of that knowledge on the farming side of it, maybe you have some insight here.
I am not the expert about soil science, or plant science. I can say what I have heard, that we do, if we're going to be using these materials that are like, especially more of a virgin product, then it needs to be considered very much. The soil resupplementation of the soil needs to be strongly considered, because the last thing we want to do is deplete the carbon storage potential from the soil. I acknowledge that a lot of the straw where I live gets burned, and so using it as a waste product is at least better than burning it. But if there could be a better option, I'd love to know it. And I think that would have to do with like the agricultural practices of maybe crop rotation and, like he mentioned, fertilizers, et cetera.
Can you guys hear me?
Thank you for that, Chris.
Oh, we can. Hey.
Sorry, I had to leave a noisy environment. I could quickly share what I know. So the benefit of perennials, of course, is the roots remain in place, and so they're not rotting and releasing carbon. I believe hemp lasts for about 3 years before it needs to be replanted. Maybe somebody could chime in on that. So there's a lot of value to that. Some limitations, of course, with wood. Trying to think what else. But yeah, like you said, straw, we're diverting it from other lesser uses. So there's some value to that.
I've heard similarly that hemp is especially good at replenishing soil.
Cool.
Yep.
We'll give it to him.
Thanks. Yeah, hemp has high nitrogen needs, but it is a perennial, so it's probably a net positive compared to some of the other ones.
Okay.
Okie dokie. It looks like our next question is from Andrew Fowler. Are you on with us right now, Andrew? Would you like to ask your question? Smash away at the unmute button. Otherwise, I'm going to go ahead and ask it. Feel free to interrupt me though, guys, if you're actually unmuted and I'm in the midst of asking your question. Lindsay, can you speak about any experience or knowledge of using rice hulls or husks for insulation? Do you know much about that?
I have seen that brought up as a thing. I don't have any experience with it. I'd love to know more.
Yeah, it seems a little niche. I'm excited to know when that kind of pops off. I'm sure it will someday. Lori Goldman. Lori, are you online? Would you like to ask your question?
Lori had to go. So
Lori had to go. Okay.
Yep.
Lori's question is wood shavings an effective insulator?
Wood shavings could be a potentially effective insulator. I think we use them either in conjunction with a binder like clay or lime, similarly to light straw clay or hemp-herd, because A, it helps hold it in place, but also B, because it reduces the flammability. So if you just had wood shavings, I think there's a lot of air in there, and it likely would be, oh, looks like someone is clarifying that yes, in the context of with clay. Yeah, I think they've been used. And there's a great foundation product out there called Durasol or Fazwal that is wood shavings in a solution, like a cementitious solution that makes them usable below grade.
No,
or
cool.
above grade, either.
Sweet.
Thank
I did not know that. All right, this one looks like it was asked and a little bit maybe answered in the chat, but Julie Blasek, it looks like you might be online if you would like to still ask this about the
Yeah.
mineral fiber. Awesome.
Thank you. And it was answered. I appreciate that. I don't know if you want to get into a little bit more about why mineral fiber isn't considered as natural as the others, but just the embodied carbon sounds like.
It's totally natural. Yeah, it is a natural product. It is just a higher embodied carbon product. It's vapor
Okay.
open. It's used very widely. It's a great product.
I'll jump in here and say that mineral wool is still the only insulation that's still using a formaldehyde binder. The
Sometimes.
fiberglass insulations got a lot of flack for that in the 90s and switched, but mineral wool, Roxol and Owens Corning are still using formaldehyde-based resin to bind the mineral fibers.
Yeah, depends on the type of
Yeah,
also.
I believe Julie's right that there are products that you can request that do not have formaldehyde.
It's those VOCs. They'll get you. All right, this is kind of a similar thing where it was asked and like kind of touched on in the chat too. So Chloe, if you'd like to ask your question, Chloe Castaneda, about invasive plants for building insulation, you totally can. If you're like, yeah, I think I got what I needed from it, that's fine too.
Yeah, so it was kind of addressed about the question was about like I'm exploring the potential of using introduced, or as most people know them, invasive plants as just sort of a new material in building materials. But I'm curious about like what sorts of binders are used in insulation bats, because like what I've seen, like Hempatexture uses PET in their bats or something like that. I could be wrong, but I'm just curious like what like non-soluble binders are used.
A great question, and I meant to point that out. I think there is a small amount of a plastic byproduct of the fabric industry that is used in many of the bats. I don't think any of the fluffy things are using binders, unless you're into like hemp and lime or straw clay. And lime and clay are fantastic binders. It reduces the R value, so you have to go to a much thicker wall. That's another thing that I didn't mention. I would love is that when we're designing with natural materials for high performance, we really do need to embrace like thick walls and thick roofs, and not like force ourselves into a situation where we have to use something with a higher R value. It can be an opportunity to create or modify our design language. But Chloe, did I answer your question?
Yeah.
Okay. Can I give a shout out to Planted, which is not an insulation material, but it is a sheathing material. I believe it's made, I'm quite confident it's in the Southwest. I want to say North or South Carolina. And it's a sheathing product that is made with this bamboo-like material that is, I believe, invasive there. I don't think they are, what's the word when you're like scavenging it from the wild? I think they're farming it, but it's a great use. Oh, thanks, John Hyde, for clarifying. North
Cool.
Carolina, grown in Texas.
I just had to find a sticky note to write that down. And
Yeah.
Kim gave us the link. Awesome. Alrighty, it looks like we have up next Paul Thompson. Paul, are you online? Would you like to ask your question?
I
looks like
am here. Thank you. This is really, can you hear me? Okay, great. Thank you. This is really interesting discussion. You know, I love wood. Not a new convert, but I think wood is the great because I love that it's reusing old industries and sort of throwaway materials that aren't being used to make paper and so forth. But my question is a practical one. I do retrofits on existing houses, and sometimes they have a new roof and solar panels, and I can only have access to the roof from below. I need to have an impermeable air barrier / insulation. Is there a natural product that is impermeable like closed cell spray foam, or do you have any thoughts about how to deal with that situation?
I'm going to say it again because I'm not sure I'm following it completely. And please correct me or fill in. I think you're saying that you need a water durable, like a hydrophobic material as insulation so that you can access the solar panels that are above.
No, if I'm renovating a house, I don't have access to the top of the roof sheathing.
Okay.
I only have access from the bottom, and so closed cell spray foam is the go-to material for impermeable insulation, and it ends up being the sort of de facto air barrier.
Right.
Is there anything natural that is code compliant and does the same thing?
Does the roof have any rigid insulation above the sheathing?
Often it doesn't.
Yeah.
Because they didn't have an architect. It wasn't thinking about what are you doing before the solar panels were installed. Now we got a situation that we need to deal with.
Okay. Unfortunately, I think that some spray foam, you know, like maybe a flash and bat option might be the best solution there.
Yeah, that's what we use.
Yeah, as much as I try to avoid it, it's like there are instances where it is kind of the right thing to do.
Right.
Interesting. I mean, everything is so case by case basis, right? My favorite thing about the building industry so far, everybody, is when you ask a question and the answer is it depends. And that's like every single question and answer ever. Alrighty, Ashley Murphy. Ashley, are you here? Would you like to ask your question about BAMCore?
Yeah, I'm here. I
Hey.
maybe I missed you talking about BAMCore, but I was just curious if you had opinions or pros and cons to that product, and does it, I don't even know what their center insulation material is. Is that a foam product or does it count as a natural material?
Yeah, it totally does. I didn't include it because I was focusing on insulations, and I think of BAMCore as more of a structural system, but it's kind of all in one, right? Like it's a system that I would consider an elegant assembly. You're stacking functions, and it's very simple. One of the things I love about it is I think you can use like any insulation in it.
Oh, wow. I didn't even know that. Yeah,
Yeah.
awesome. Really great presentation. Thank you.
Okay, let's wrap up a little bit with some of these questions. If you have something that you're like, oh, I kind of want to ask, but I'm a little shy, just ask it. Just ask it. Again, we're all the nerds. We're here. We're excited. Angus Funkhauser, are you here? Would you like to ask your question? Looks like air barriers, kind of related.
I am. So let's step out of
Hey,
class real
Angus.
quick.
Uh-oh.
Haven't started yet, so but so I was wondering about your experience with dealing with air barriers when dealing with like natural materials that need to like breathe. So yeah, I guess that's my question.
That's a really broad question, but it's a good one. I was kind of hoping we could dive into some specific assemblies. I like to stick with air barriers that are vapor open in general. And there's so many different options nowadays. Like you can have an air barrier at any plane of the building wall or roof. And it really depends on so many factors, so many other factors of your assembly. I kind of like start to narrow down. I don't know if this is exactly answering your question, but I might answer it from a perspective of like, how do I get to an answer in a particular project? If that's helpful. And just interrupt me if I'm on the wrong track. I welcome the conversation. I think I typically start to think about the project constraints in terms of like, what are the structural and fire considerations first and foremost, and then second, what are the client desires from a finishing perspective? And then from there, I consider like what options are more locally or regionally available. And then from there, I think about what's the air barrier strategy that might work best with those insulation and structural components. I could talk about a specific project. And if we have time, I could get into two to compare and contrast, but working on a project with an architect up in Northern Canada, they're only 8 hours away from the Savic factory. Who knows what's going to happen with tariffs, TBD. But we've evaluated the various straw bale panel SIP options, and fire resistance is their highest priority, and they also really love a plaster aesthetic. So Savic made a lot of sense, and they haven't determined for sure yet, but Savic kind of makes sense from that perspective of like regionally available. And actually, sorry, I want to go back a little bit. They are regionally available. They offer fire resistant solutions. They are not the most fire resistant panel. They can be depending on the finishes, but because Savic's panels are very much like a conventional cellulose wall, you've got sheathing on the outside. You can do wood fiberboard insulation, and you could use one that you can plaster directly to, therefore improving the fire resistance of the assembly. But there are air barriers on the interior, and then that creates an opportunity for a service cavity to protect that, and then you're automatically applying, like, I guess someone could choose lath. I love lath and plaster, but most people are going to probably default to sheetrock. I hope that kind of answers your question of how I approach it.
I thought that was an informative answer. Okay, I'm going to read a question out for Pamela. Let's see. Is this presentation focused more on residential? I see multi-story buildings in Ottawa, Ontario covered in foam. What natural options exist where exterior walls may be exposed for a while before the outside siding is installed?
That's a great question. I know that the various wood fiberboard insulations have different like longevity abilities, and if you look on their specifications from the manufacturer, they will tell you what those are. And then combining that with a building wrap, an appropriate building wrap, is the approach I would take. Weather resistant barrier. Even if the wood fiber could operate as the WRB, you might just want to build in that extra layer of protection.
Better safe than sorry, I guess, in that case. Okay, let's see. I have Jeff Graham. Jeff Graham, are you on? Would you like to ask your question? It's a very specific question about air barrier
It is
stuff.
quite specific. Yeah.
Awesome.
So I'm in Zone 6 in Canada, and I work for a company I'm a carpenter. I work for a company that does like high performance air tests and everything like this. But we're starting to, we've wanted for a while to get into natural materials, and we have a client we're building in April, May. We're working with an engineering firm that is informed, but I just want to get as many sources of information as I can. My question is, I'm wondering about the air barrier continuity between where you're going to be using a rothoblast outside. I can't remember the name of the actual model of the rothoblast. It's the European air barrier for the outside. Mm-hmm. Connecting that to the sub slab typically we use a polyurethane subslab insulation. And that's the detail that I haven't seen yet. I'm not sure how we're going to be insulating the subslab. So there's that junction between the subslab interior air barrier to the outside. On the inside of the wall, it will be a Intello Plus. So there's a connection of the subslab to the air barrier outside, and then at the top of the wall, at the truss level, wrapping in the air barrier. Are those junctions particularly critical with natural materials? On the outside of our wall, it's going to be an MSL panel, so an R4 on the outside of the wall. In the cavity, it's going to be a hemp fiber bat insulation. And then on the interior of the wall, there's going to be another. I refer to it as a tin test. It's a wood fiber panel, and the company working with the hemp, they're going to be doing a lime plaster finish on the inside of that. So it is. There's no plastics except for in the actual air barrier materials. And so yeah, the junction, the subslab, the truss at the top of the wall. What recommendations do you have? Yeah, is that specific enough?
Yeah, that is a very specific question. I'd probably want to see drawings before I, like, I don't want any liability for this, but like,
Right.
Those junctions are critical in any building from an air sealing perspective.
Yeah.
Those are exactly the places that you got to figure out, that are not straightforward. I think I'm just thinking that like a liquid applied membrane might serve you well, which is definitely full of chemicals, but it's a small amount of it, and it might be the thing that enables you to justify these other materials that you're using elsewhere, potentially. That's for the base, the foundation, floor, wall intersection. And then at the top, where the wall is meeting a roof, you can usually resolve that with thinking through the sequencing of application of the air barrier membrane, like lapping it to connect with the next component.
Mm-hmm. Okay. And when we talk about the importance of air barrier continuity with natural building materials, how are the risks different from an air tightness perspective? How would the longevity of the wall? Yeah.
Well, okay, so actually what I'm realizing is that like when we're using membranes, it's very often that we're using like cellulose. I guess there are a lot of people who use fiberglass, and I'm under the impression that cellulose actually deals with water better than fiberglass. Like it can store a little bit of it, without creating potential for mold in the adjacent members or within itself. So I could be proven wrong, but my impression is that cellulose is better, and then hemp hemp is also very water resilient. So in terms of like whether they perform better or worse, or you have to be more careful, or the risk is greater, I think the risk is the same. I think that
Okay.
the risk, you need to think through those connections and make sure that water is like, it's probably going to get in. So you need to ensure that it's got a way to get out.
Okay. So with natural building materials, it's just that much more important to not just put a standard polyethylene on the inside as the vapor barrier, but to put a vapor open or a vapor, the ones that change with humidity.
Yes, a smart vapor.
Smart vapor, yeah.
Vapor
control.
membrane.
Thank you.
Yeah. And I will say, like, I've done a lot of repairs in the past year or so, and I'm noticing situations with like straw bale, lime, and clay, where if it was a cavity wall situation, and the amount of water that had gotten in, like it would have been a catastrophic failure in a cavity situation. The straw bale wall with lime and clay was able to deal with it with time and drying potential, it was a very small repair situation. And one thing I didn't even mention is that when you're repairing natural material buildings, all the materials like can either be reused or they're biodegradable. Like nothing has to go to the landfill. So that's a huge bonus as well.
Thank you.
Man,
Hopefully that answered it.
awesome insights there. Also, Jeff, in the chat, make sure you take a look. So it looks like Marcus also gave you a little tidbit of info there. All right, we have two last questions. I'm gonna kind of try to poke and prod y'all to wrap it a little bit so we can get out of here by 10:15-ish. Carl Eklund, it looks like you are up next. Would you like to ask your question?
Yeah, what do you mean by vapor open? I think you were talking about exterior insulation. What do you, in terms of perms, like 7 perms, 50 perms?
Oh, geez, this is a great question, but I never remember numbers like that. I always have to go back and look them up.
Okay.
I bet there's someone else on this call who can rattle that off on the top of their head, off the top.
Okay, great.
Yeah. I think I respond more to like the properties of the material, like is it porous? Is it not porous?
Okay.
Yeah.
Good enough. Thanks.
Sorry.
Oh, I'm sure someone in this group can pop off on that one for you, Carl. Okay, last question. Justin Taylor, would you like to ask your question, Justin? I see ya.
Hi. Yeah,
Hi.
thank you for the presentation. And no pressure, there was the last question. I've for a while now, I've been really interested in using cork. I've tried to get it in a few projects now, specifically in trying to do it as a insulation and siding. Have you been able to see that? Well, have you been able to use that in a project successfully? And is there any pushback from clients? Just curious, like even from the manufacturers, sometimes they don't seem to be as knowledgeable because I guess it's not as much done here. So I just wanted to get your take on that.
Yeah, thank you. I have not actually tried to implement cork in a project. There is someone else on this call who I know has. Jacob, I'm looking at you. I don't know if you tried to use it in a residential project. But if you could speak to that, feel free to pipe up. Type something in the comments or.
No, I haven't used it in residential. I kind of use it in an experimental way as a exterior pavilion, to kind of test it out. I would definitely look at Moon Tower, and specifically their Austin project, I think is an incredible example. They've got multiple projects that they're installing residential cork. I would also order a sample, whether you have a project or not. It's so fascinating to see in real life and put out. I actually got 2 samples, one to keep inside and one to have it weathered outside. So I kind of did quite a bit of testing before it, but I even submerged it in a bucket full of water and pulled it. I did all sorts of tests on it. And it was only became more and more fascinated by its potential. So I think the best way to gain confidence with it is to get it in your hands and talk to Moon Tower. They're super responsive, and they'll jump on a FaceTime call and talk you through everything. So they also have on YouTube a very good tour of one of their case study projects, which they dive into a lot of specifics, which I recommend. So.
Great, thank you. Yeah, we got a big sample of a cork panel already in the office, which is great. Like you said, it's just great to have. And I think it was from Small Planet Supply, so it was great to be able to get a hands on that. And yeah, definitely recommend it as well. But it's more about the client interaction and getting them to be comfortable with it and all these things. And that's what I'm curious, is definitely Moon Tower, they did their own project, And it wasn't so much about for selling it to a client. So that's why I was interested from like talking to clients about that.
Yeah, and I think I think this goes for a lot of natural materials. I see a lot of builders that are promoting natural materials and they don't hire like a good designer. And I think that's me as my role is to promote these natural materials as like a I don't know. I think that yeah, that was one of the reasons is to kind of present it in the public's eye as a well-designed piece apart or in addition to it being a healthy material choice. I think that goes a long ways too, because I think often natural materials, clients that are not well educated about them kind of that there's still kind of this notion that people think that their house is going to fall apart or something. And so I specifically am trying to promote stronger, more durable, more reliable natural materials with good aesthetics and kind of pairing that as like just good, like very well designed residential and commercial structures. So if that makes sense, that's a whole nother discussion.
Yeah, we can't forget the whole design portion of all these projects. That does matter a lot.
Especially with cork, that's the thing. There's a really thin line between it looking unfinished to presenting it as, no, this is the finished product, like it's raw. And I presented it as like, it's going to weather really quickly. Like it only took like 2 months for it to start changing color. And it was like, you're embracing a natural material and kind of promoting it as like, as that's the beauty of it, instead of, promoting it as like, I don't know, as something that will not change, that's another thing that, exactly. So.
Well, it sounds like we need to have a cork AMA, Zach.
It does indeed.
And
absolutely.
That means that I implore you all to join us at the Reimagine Buildings Collective, where we will deep dive into cork as building nerds.